Going on to number 30 in the book. If y'all want to pause it and read, then we'll come back together and work on it together. Well, it looks like we got ourselves another bearing problem. From point P, a Boy Scout troop's going to hike in the direction of northwest to point Q. So we're going to go north 38 degrees west to point Q, and then at point Q, the scout troop's going to turn and hike 1.82 miles in the direction of southwest. So we're going to go northwest, then we're going to go southwest to their destination point D. If D is northwest from point P, we want to determine the distance between points P and Q. Okay, so we have P to Q and then to D. Alright, let's get ourselves a picture drawn. First of all, starting at point P, we're going to go north 38 degrees 10 minutes west. Okay, so here's my point starting out. I'm going to go from the north, I'm going to go to the west, right there. And they said 38 degrees and 10 minutes. Okay, they didn't exactly tell us how far we walked, but at least they told us we went to there. Okay, and then from our next point, we turned and went southwest. And we did that by about 11 degrees and 20 minutes, so very short angle right there. So I'll call that 11 degrees and 20 minutes with 1.82 being my distance. Okay, and that gives us to point D. Alright, so let's go back to the problem for just a second. I've forgotten some of it, and they say, let's see, if point D is northwest 58 degrees and 10 minutes from P, we want to determine the distance between P and Q. So north 58 degrees 10 west from P. Okay, so from P, looks like I'm going to have to draw this out a little bit bigger, because the only way I can get a northwest angle, this is a little bit further down. Yeah, that looks about right. Okay, so let me recreate this. So far, that was 38 degrees and 10 minutes. And then let me draw this in here. They tell us that last little piece of information is to get, let me pull that back up for you guys again. It says if point D is northwest from P, so from P it's north to the west 5810. So from P, from the north to the west, so all of that angle right there is 58 degrees and 10 minutes. Okay, so let me get this other one out of the way so we have a clear picture. And then we can get started with our problem. So they want to find out the distance from P to Q. Okay, well, let's take some information that I know. Let's draw up some pictures. If that right there is 3810, then this right here also has to be 38 degrees and 10 minutes. Okay, if all of that is 5810 and that's 3810, then just inside here, if we call that theta, theta is going to be 58 degrees and 10 minutes minus 38 degrees and 10 minutes. So 38 and 58 will give you exactly 20 degrees. So that's what theta is going to be right in there. So if I know all of this upper angle all the way across, I know that all the way across, then I can definitely get that one. So if we call that alpha, then alpha is going to basically be 180 degrees minus, let's see, the sum of 1120 and 3810, which is all that upper one, and then minus the small little one we just found, which was 20 degrees. Okay, so if we combine all that together, we'll find alpha real quick. And when I do the math, I get alpha to be 110 degrees and 30 minutes. Alright, let's see if we can start doing the law of sines and see if we've got enough information here. I want to find x, so x over the sine of the angle opposite that, which is what we just found, is going to be another side, which is 1.82, divided by the angle opposite that, which was theta, is 20 degrees. And I need to put sine in there real quick, so it'll be the sine of 20 degrees. So solving it out, x is going to be 1.82 times the sine of 110 degrees in 30 minutes, all divided by the sine of 20 degrees. So plugging all that into our calculator, we'll get our answer. And we probably need to round it to about 3 significant digits. So why don't we call it 4.98 miles. Box that up, and we are ready for our next problem.